I am Anil Kumar. Welcome to my series on Algebra 1. In the last class, we learned about algebraic expressions. Now, we will see how do we solve application questions with algebraic expressions. Here are a few types of questions which we are going to take. We'll first learn how do we really apply distributive property for doing fast calculations. Then we will have a set of problems. Most of them will be related to geometrical shape or money. So you'll find area of equilateral triangle, volume of right circular cone, we'll work with money, we'll find area and perimeter of rectangle. There will be a test question based on Pythagorean theorem, and finally you will get an assignment to complete. This assignment will be based on financial applications. Okay, let us recall what we learned in the last class. Here are a few key definitions. Basically, we focused on algebraic expression, which could be written as something like 3x squared minus x plus 5. Correct? So we look at this expression while understanding our definitions. We define the variable. What is a variable? Well, variable is a symbol used to represent unspecified quantity or value. That means the value x, the unknown. Unknown which can take any value. That is a variable. In this equation, I should say expression, the variable is x, right? At times, we use this word pronumeral. So pronumeral is also a symbol. So as written here is a symbol that represents a particular number or a numeral, right? So particular number, the best example is pi. So pi has a fixed value, correct? It is not unknown, but we use the symbol pi for it. Example, circumference of a circle is 2 pi r. Do you see that pi in it? So pi is a pronumeral. We will never call this as a variable since it has a constant number associated with it. Is that clear to you, right? Okay. Now, algebra. So what do you think is algebra? In algebra, we have seen that there are three basic components. These basic components are variable, numbers, and operations. Perfect. So algebra is a branch of mathematics that deals with variables, numbers, and various operations on them. Perfect. Easy. Algebraic expression is the major topic. In algebraic expression, we have variable, numbers, and operations. Perfect. There is no equal to sign. Remember this. The combinations of all this, right? So the definition here is an algebraic expression is combination of sum and or product of numbers and variables, right? For example, the expression shown here, 3x squared minus x plus 5. It is an expression which has 3x squared, which is product of variables and numbers, correct? X just a variable, 5 just a number. So combination of all these or their products, and they're separated by plus or minus operators. You can add and subtract these terms. You get the idea. So number of terms is 3 in this particular case. Okay, so let's go through the definition of algebraic expression once again. An algebraic expression is combination of sum and or product of numbers and variables. It can have one or more terms. For example, here we have three different terms, right? Separated by addition or subtraction operation. So these three terms, they are separated by minus is subtraction, plus is addition. You get the idea. That is how we define an expression. Perfect. And this expression, as you've seen, has three terms. One of the term is 3x squared, the other one is x, and the last term here is 5, which is a constant. Those two are variable associated terms. Verbal expression. Verbal expression is an algebraic expression that is expressed in words. So I could say this, that 3 times square of x minus x plus 5. That becomes a verbal expression, correct? Term, term of an expression can be a number, a variable, or product of number and variable, as you see here, right? So in this particular case, we have three different terms. This is product of number and variable. This is just a variable, and then we have a number. So any combination of these. Coefficient. Now, coefficient is a term which is the number associated with the variable, correct? Coefficient of term is the numerical factor, we can say. Factor means when you multiply two numbers, you get a product, and the numbers or whatever is multiplied is the factor of the product, correct? So in this case, the coefficient is always a numerical factor. So the numerical value is 3. That becomes the coefficient of x square. In this case, can you tell me the coefficient of minus x? Well, minus 1 is the coefficient of minus x. So we have written here, coefficient of the terms, 3x square is 3 and minus x is minus 1. You get the idea, right? In the given expression. Perfect. Now, can you summarize, or do you understand all these definitions? Any doubts? So I hope it is absolutely clear. Now, here is a question for you. What is a factor? Think about it. When you multiply two things and get a product, those two things are the factors of the product. Perfect. So now, let's move on with our examples. The very first example is based on distributive property. The question here is, a group including 10 students and 2 teachers went for the Science Museum. The ticket cost for members of a group is $5 each. So $5 each is the cost in a group. Whether you are a student or a teacher, the ticket cost is $5 for a group. Is that clear to you? Now, using this information, the questions are A. Use distributive property to express the total ticket cost. And B is evaluate the expression to find the total ticket cost in dollars. So part A is to use distributive property. Now, how do we use distributive property for this particular question? Think about it and let me know. Yes, there are 10 students and 2 teachers, and the cost for both of them is $5 each. So we could write 5 and within bracket the numbers, which are 10 students and 2 teachers. Do you see that? So once you have a product, this is a product, correct? So if you write a product and then you expand, that means we'll now multiply with 5 both the terms inside. So what do we get? We get 5 times 10 plus 5 times 2, right? And this can be written as 50 plus 10, and that is equal to 60, correct? And this is equal to 60, as you can see. So now, if you see the second step, we got from product to sum. That is distributive property. In distributive property, we will write first product of two things and then expand to write it in terms of terms, sum of different terms. Perfect? So that is what it is. So as you can see in this particular example, we use the distributive property to express the total cost. So this is the total cost as expressed here, right? Now, when you apply the distributive property, that is what you get. Now the question was, evaluate the expression to find the total cost. To evaluate, just find the sum of 50 and 10. So you get the total cost as $60, right? So the cost is equal to $60 as shown here. Is this clear to you? A very straightforward question. We just wrote the expression from the statement given to us, right? Now let's take another example. Example number 2 is based on mental math. The question here is, use distributive property to write each expression, then evaluate. So these are two-step problems. You have to first write them as a mathematical statement and then evaluate based on the given value. Is that clear to you? Okay, so I like you to look at it, go for the solution, and let me know who got what answer. Well, we have to multiply 28 by 51 for A, and in B, we have a very complicated fraction, 8 1 over 7, which will be multiplied by 7. Let us see. How can we do it? Well, 51 can be written as sum of 50 and 1. So we could write this as 28 times 50 plus 1. And now the distributive property can be applied. It's an application of distributive property. We'll multiply first by 28 times 50 and then 28 times 1 to get our answer, right? So we get 28 times 50. See, multiplication by 50 and 100 is very easy, right? And even with 1. So that simplifies the word. So 28 times 50 is kind of 2800 half. 50 is half of 100, right? So it could be half of this, right? And then 100 plus 28. And that gives us the value 1428. Is that clear to you? So remember that part. You can actually multiply by 50 means times 100 by 2, divide by 2, right? So the key here is 50 could also be considered as 100 divided by 2. That is even simpler. Now, that was easy, right? All of you must have got it. The next one here is 8 1 over 7 times 7. How do we do this one? Well, let's try to understand the meaning of 8 1 over 7. It really means 8 plus 1 over 7. Do you see that? So we have 8 plus 1 over 7, which is 8 1 over 7. We are going to multiply this by 7. Now we already have a product. That means we could apply the distributive property, right? So this time multiplying from the right side. Perfect. Now we can write this as 8 times 7 plus 1 over 7 times 7. We get 8 times 7 as 56, and 7 divided by 7 is 1, and therefore the answer is 57. Do you see how simple it is? That is how distributive property helps us for easy calculations. Now let's take the next example. Example 3 will relate two variables in this particular example. Okay, so let us see how we are going to relate it. The question here is, let F and S be the present age of father and son, respectively. So F for father, S for son. Relate the two variables for the following conditions. Well, we have given here capital F and capital S. So we'll use the same letters. Discuss problem solving strategies and then provide the solution. So I'll appreciate if you could think about the problem solving strategy in your mind, come up with the solution, and then we can discuss it. Well, A. Father is 3 times as old as son. Relate present age of father and son. We know father's age is F, so we'll write F for father. Is really means equal to. Is 3 times as old as his son. 3 times S. Does it make sense to you? So father is equals to 3 times S. So that becomes our equation. In this equation, 3 times S is an expression for the age of father. You get the idea? So father's age is 3 times son's age, 3S. Okay? So relate present age of father and son, that becomes the relation. Do you see how simple it is? But with this example, where are we going? Do you see how we have expression? And from there, we move to equation. In problem solving, many times, when we have to solve, we may have to equate two things, just as we equated with an equal to sign. So there is an overlap now from expressions to equations, and that is also our next chapter. So the idea here is to introduce you to equations as we master the techniques of solving or simplifying expressions. You get the idea. So we'll have a mixed up approach now. So that is how you could do this. Part B is 4 years ago, find the age of father. 4 years ago, father must be younger. So F is the present age minus 4 becomes the father's age 4 years ago. Perfect. C is write expression for son's age 4 years ago. S minus 4. Take away 4, you'll be 4 years younger. 4 years ago. D is 4 years ago, father was 4 times as old as his son. So this age, 4 years ago, father was 4 times. That means we could write this as f minus 4 is age of father 4 years ago, which is 4 times age of son, which is s minus 4. 4 years ago. Do you see that? So we actually got an equation. Express the above sentence as an equation. Do you see that? Now, when it becomes a complete sentence, what we get here? We get an equation. Do you see that? So we got an equation since we started with the sentence. You will notice that this is also a complete sentence. Father is 3 times as old as his son. A complete sentence which gives us an equation. The other two, B and C, are expressions. 4 years ago, find age of father. 4 years ago. It's incomplete, kind of, right? So what we get here is an expression. But anyway, we have understood a strategy to solve age-related word problems with the help of this example. You see that? And also notice that when we are talking about equation, what do we have on the left side? An expression. On the right side, also an expression. Do you see this? So this is an expression, and that is also an expression. With equal to sign in between, it makes an equation. So in an equation, you might have expressions on either side with equal to sign. You can always solve such equations. You understand? Okay, let's move on since our focus today is on expressions, right? So we relate it to expressions. When we do so, it forms an equation. That is the learning from example 3. Let's see what is there in example 4. Well, it says algebraic formula working with variables. It is important to remember that when we have an expression, it could be treated as a formula also. We are going to see it in this particular example. The question here is, area of a triangle is half base, which is b, times height h. So this is the information given to us. Area of a triangle. Part A is write an expression for area of triangle. Well, so first let's define a variable a for area. In that case, area of the triangle is what? Area of triangle A is half base b times height h. So just as we read it, half base is b times h. So that becomes the area of a triangle. Perfect. So we turn the expression into the phrase into the expression, getting us the formula. Do you see the idea? So we actually got a formula for area of a triangle with the help of the expression half base b times height. Perfect. So we've done part A. Part B is find height of equilateral triangle with base length of 2x. Okay. So on the side, I have a triangle. Each side of this triangle is 2x. That means it's an equilateral triangle. We need to find the height of this triangle. This is the height of the triangle. Can you suggest how can we find height of this triangle? Well, this is to be perpendicular. Since it is equilateral triangle, each side it divides into equal parts. So the perpendicular from the vertex divides the base into two equal parts and each will be x units because the total length is 2x. So each is x units long. To find the height, we can apply the Pythagorean theorem, correct? Which is a square plus b square is c square. You remember Pythagorean theorem? A square plus b square is equal to c square, where c is the hypotenuse. Perfect. So therefore, the hypotenuse is 2x in this case, since each side is of length 2x. So we can write 2x whole square. Let's write down. So we can write 2x whole square should be equal to what? Square of this side, which is x only, plus height, which we don't know. Let's write this as h, the variable. Square of that. So we need to find height of equilateral triangle. So in an equilateral triangle, all sides are equal. We have taken a triangle with length 2x each. So we can isolate h square by taking away x square. So we get, let's square this first, 4x square, right? And we will take away x square to find the value of h square. So this is 3x square is equals to h square. So what is h equals to? Square root, right? So we have the formula, height should be equal to square root of 3x square, and that gives you x times square root 3. So we've solved part B, which was slightly tricky. We're going to learn some of these techniques in the next class also. We'll see how do we really solve an equation. Perfect. So for the time being, take it as an advanced class where you're learning some features which are soon to come. Okay. So we rearranged our formula to find the value of height in this particular triangle. Perfect. Now, let's move on to part C, which is write an expression for area of an equilateral triangle if the base is of length 2x. So we know the formula, which is a equals to half of base times height. We are given that base is 2x. So now, we are given base is equals to 2x. We know the height, let me write here, is equals to x square root 3. And therefore, what is the area? Area will be half, base is 2x, right, times the height, which is x times square root 3. Now we can calculate. Cancelling common numbers in the numerator and denominator, we get the value of A. Area of a right area of equilateral triangle will be square root 3x square. Is that clear? Where the base is 2x, right? So that is how we'll get the solution for part C. Well, I'm going to share with you this particular video. After the class, you can always watch this again and go through these questions. Very important. This one especially, right? So homework. You need to go through this solution once and understand. Perfect. We're going to take similar questions in the next class also. So let's move on and take up example 5. Example 5. Write algebraic formula for volume of cone. Well, volume of cone formula is known to some of you. Here, we have written it in the form of a verbal statement, which is volume of right circular cone is 1/3 pi times the radius r squared multiplied by the height h, right? So read it again. What is the volume? Volume of a right circular cone is 1/3 pi times the radius r squared multiplied by the height h. Part A is write an expression for the volume of the cone. So I'd like you to take a moment, write down the expression for the volume of the cone and then check with my solution. Okay, so let the volume be V. In that case, volume V is given to us as 1/3 1/3 pi times the radius squared multiplied by height. So that becomes the volume of the cone. So here is a cone drawn For your reference, base is a circle. Pi r square becomes the area of the base and height is h for this particular cone. Whenever we have pyramids or cone, their volume is 1/3 of their equivalent prisms. Is that okay? That's the key. Okay, part B. Write an expression for the volume of the cone in terms of the variable h if the radius of the base is twice the height. We are saying radius is equal to twice the height. In that case, write down the formula in terms of height. You get the idea. Okay, so let's do it. So that is basically replacing r with 2h. So we'll get volume equals to 1 over 3 pi. Replace r with 2h. We get 2h whole square times h. Expand. We get 1 over 3 pi. 2 square is 4. H square is h square multiplied by h. So we get 1 over 3 pi. 4, I could write 4 here. 4 over 3 it becomes pi. H square times h is h cube. So that becomes another formula. But in this formula, the only unknown is the height of the cone. Since we have written radius in terms of height. You see how we sometimes rewrite our equation in only one variable. Do you see the beauty? So we have done part B. Here is part C for you, which is write an expression for the volume of the cone in terms of variable r this time if the radius of the base is twice the height. Again, I have given, so in the first one, let's read carefully. Write the expression for the volume of the cone in terms of the variable h if the radius of the base is twice. We wrote the same thing. Let me just change this part, okay? In which radius, instead of writing radius, we'll say height variable, okay. Write an expression for the volume of the cone in terms of variable r if the radius of the base is twice the height. So we can actually, since we need to write in terms of r, we are given r is twice the height. So what is height equals to? When I say r is 2 times height, it means what? It means height is r divided by 2. You get the idea. So this time, since you need to write the expression in terms of radius, you will write height as r by 2 in the given formula. So let's use a different ink and write it here. So we know volume is equal to 1 by 3 pi r square h. And we know h is half of the radius. So we can write this volume as 1 by 3 pi r square times r by 2. That gives you what? Half and half, 1/3 gives 1 over 6 pi r cubed. Do you see that? So that becomes your formula in terms of radius if we are working with a cone where r is equals to 2h. That means height is equals to r divided by 2. Is that clear to you? So we have rearranged our formula in many different ways. We began with an expression, actually a verbal expression. So here what you notice is that we have a verbal expression. From there we got a formula. And formula we could write in terms of any variable. In this formula, there were two variables. We related both the variables and got different formula with just one variable. I hope you find it interesting. This is a very useful technique to solve some very difficult questions, correct? Okay, let's move on and take the next example, which is example 6 for us. Write algebraic expression to calculate amount of money. The question is, Peter has n nickels and d dimes. Write an algebraic expression for the amount in dollars if value of nickel is 5 cents and dimes is 10 cents, right? So let's say we have nickel, right? So let's say N is nickel. Nickel is equal to 5 cents. In dollars, this is equal to what? In dollars, it is equal to 0.05, right? Cents is 100th. Correct. As far as dimes, let's say D is 10 cents, right? In dollars, we could write this as 0.10, tenth. Tenth is done. Now it says, write an expression for the amount. So what is the amount equals to? So if you have N nickels and D dimes, each nickel is worth 5 cents. Each dime is worth 10 cents. So the total amount, you can write amount A in dollars, of course, will be equal to N times 0.05. We normally write the number first. So 0 times 0.5 N plus 0.10 dimes. So that is how we could write our amount if we know how many dimes and how many nickels are there. Perfect. If we talk about quarters, it will be multiplied by 0.25. So these expressions which we are looking at are small bits of information which can help us solve a bigger question. You understand? That is why we are looking into these small units one by one. So the strategy here is to break down the application question into smaller units, write their expressions, and relate them to find the solution. Do you see that? So what is the strategy learned here? Let's write down the strategy. Strategy is break down in small units. That is the first. Then write expressions. Once you have expressions, then you relate them. And that helps us to provide the solution. Do you see that? So that is going to be the strategy when we take up more questions. When we're talking about expressions, we're actually learning the strategy to break down into smaller pieces. Perfect. That is the part which we are doing now in this video. And in the next lesson, we'll see how do we relate them and find the solution. You get the idea. So that is a very important step moving forward. Next example here is write algebraic expression to represent a real life situation. The question here is, length of a rectangle is 5 more than the width W, right? So let us say we have a rectangle, width is W, length is how much? 5 more than. 5 more than means W plus 5. So that becomes the length of this particular rectangle. Is it clear to you? So when you sketch, then it becomes absolutely clear. We know this is also width, right? So that is how we have our rectangle. Now let us answer part A, which is write an expression for the perimeter of rectangle in terms of variable W. So only one variable. What is perimeter? Perimeter is sum of all the sides. So let's add them up, right? So we have, actually it is length plus W plus W. But we know that length is 5 plus W. So we can write this as 5 plus W plus 5 plus W plus 2 widths, right? Now we can combine the like terms, right? Like apples, apples, and apples, you can combine them all, right? So like terms. So let us combine like terms. So when you do so, what do you get? We got 1, 2, 3, 4 W's, and 5 and 5 is 10. So we get 10 plus 4 W. Is that clear to you? So that is how we could answer part A, which is write an expression for perimeter of rectangle in terms of the variable W when this condition is given to us. Is that clear to you? Part B. Write an expression for area of rectangle in terms of variable W. So area will be length into W, right? Length into width. Okay. We know what length is. We know length is equal to, let me write down here, is 5 more than the width. So we're going to replace this with width plus 5 and going to multiply this with W. Now, applying the distributive property, we can write down the answer. Is that clear to you? So that gives us W times W plus 5 times W, which is W square plus 5W. Is that clear to you? So that is how we actually write down all our answers. Clear? Now one thing is very important. At times you may use units. So for a perimeter, let the unit be just unit, and for area it will be unit square, correct? So it's a good idea to introduce units even when we are working with expressions. It's a unit of length when we talk about perimeter, but when we talk about area, it is unit of area, which is length unit square, length times length. I hope that makes sense. Let's move further and see what do we have. Well, these are 4 questions for you. So I'd like you to take a moment. You can take a picture of this particular page or copy this question, and that is your assignment, or I may say homework, right? So try to do these questions on your own, and then in our next class, we'll discuss the solutions of these questions also. Perfect. So question number 1 here is, sum of two numbers is 25. Write an expression for the smaller number n in terms of the larger number m. B. Perimeter of a rectangle of length L is P. Write an expression for the width of the rectangle. Very interesting question. This time we have given you the perimeter. We want to find the length or the width, right? C. The girls' soccer team held a fundraising car wash. They charged $5 for each car and $8 for each van. Write an expression for the money raised if they washed 80 cars and V vans. Right. D is 40 centimeter wire is bent to form a circle with the radius 5 centimeters. Write an expression for the remaining length of the wire. Very interesting question. Remember, we have also given you 2 things. Circumference of the circle is 2 pi r and area of the circle is pi r square. You may need one of this information. 40 centimeter wire is bent to form a circle. So we have a circle here. After the circle, some wire is left. But the circle is given to us with the radius of 5 centimeters. So we have the radius, which is 5 centimeter. So circumference of the circle should be deducted from 40, right? So total is 40. Now that should help you to answer this question. Perfect. So I hope you enjoyed this journey of how do we write expressions in the given situations and then solve some of them. These 4 questions are good for you to begin with. Here is an assignment which we shared with you earlier. Well, let me see if you have already done this assignment. Assignment is, consider the verbal expression. The expression is thrice the sum of 2a and b decreased by the difference of a and 2b, right? Write the algebraic expression for the above verbal expression. Let me know your answers. What have you got? Thrice the sum of, so 3 times the sum of 2a and b. The word and is very critical. The sum of 2a and b, this comes in brackets. So 2a plus b. You get the idea? Thrice the sum of 2a and b decreased by, means minus comes here, the difference of a and 2b. The difference of a and 2b. That becomes the expression for the given phrase. You see? That is how you have to write your expression. Part B is combine like terms to simplify the expression. So let's apply the distributive property and then open these brackets, combine the like terms. So when you multiply 3 times 2a, you get 6a, plus 3 times b is 3b, minus 1 times a is minus a, minus minus makes it plus, 2b. Do you see that? Now, do you notice some like terms? Yes, we do. We have the like terms. We can combine them. So let's combine them and write down. 2a minus 6a minus a is 5a. Perfect. 3b plus 2b is 5b. So that is how we can combine the like terms and write down. Correct? Then we have to mention the property. The property here is distributive property. Correct? Okay, evaluate the expression for a equals to 5 and b equals to 2. So substitute 5 for a and 2 for b. So if we do that, what do we get? 5 times 5 plus 5 times 2. So 25 plus 10 gives us 35 as the answer. So that is how we are going to solve this assignment question. I hope it is absolutely clear. So if any one of you have doubts, please ask. Okay, raise your hands. Well, here is your test from today's learnings. I'd like you to focus on the question shown on the screen. Read it, try to understand, and tell me or share with me the strategy of solving this question. Okay, let's read this question. Area of right triangle with base b centimeters is 100 centimeters square. So we have a right triangle here whose base is b and the area is 100 centimeters square. Write an expression for the altitude or the height. So this is the height of the triangle. We have to write down the expression what should height be. So clearly we are applying the Pythagorean theorem, right? Then we have write an expression for the perimeter of the triangle in terms of b. So we have to write perimeter, which is sum of all the sides in terms of b. Is that clear to you? Perfect. So I'd like you to use the information given and answer the question. We are given in this particular case that area A is equal to 100, right? The formula for area of a triangle is also given to us. Area is half base into height, the altitude, right? So you can use this particular formula. We have the base as b. In terms of b, you have to find the hypotenuse, right? So let me use, instead of height as h, let me write the variable a for height. Is that okay? Then you can directly use this formula and we'll write h for the hypotenuse. Is that clear to you? Or okay, just write c for hypotenuse, no problems. You can choose any variable you want and then work out the equation, correct? So that is how you could do it. So this is your test question. Now, the final assignment at the end of this unit. The assignment here is based on financial application. I'd like you to read the question, understand, and then solve it. In the next class, we'll see how do we solve this assignment, okay? You need to submit your assignment before that. Under certain law, the first $50,000 of earning are subjected to a 25% tax. Earnings greater than 50,000 and up to 100,000 are subjected to 35% tax. And the earnings greater than 100,000 are subjected to 55%. Write expressions to model this situation, explain the strategy. Use your expression to calculate the tax for earnings of $70,000. Tax on earnings of $200,000 is $110,000. Is this statement true? Support your answer. So these are the three questions which are based on the information given to us. You need to answer this. Remember one thing, we are talking about three different categories. In the first category, certain law, we have from earnings which are from 0 to, let's say earnings is X and this amount is from 0 to 50,000. Where 50,000 is included and we have a tax rate which is 25%. That is how you could systematically break it down into smaller units. And in the next you have from 50,000 above 50,000, correct? To a value which is 100,000, where 100,000 is included. We have a tax rate of 35%. And if it is greater than 100,000, in that case, the tax rate is 55%. Now that should make it much simpler. So based on this information given to you, I'd like you to submit the assignment, right? Follow steps and the strategies which you have learned to get to the answer. I hope that makes it interesting and useful, right? So in this particular set where we're talking about algebraic expressions, we began with how does arithmetic connect with algebra is the variable which connects them, right? So the key was variable. When we talk about a variable, we are actually solving for unknown. So this is solving for unknown. So that's the beauty. When we bring algebra into picture, we can actually solve many questions where things are unknown by relating the variables. How do we relate the variables? We relate the variables with expressions. And one of the most important tools was how do we convert the verbal expressions into mathematical statements? And we had a kind of link between them, only four operators to look into plus, minus, multiply, and divide. Exponent is multiplication, correct? So, different terms can help you get the key idea. That helps you to form the expression. And then we learn how do we apply the distributive property to work with expressions. Multiplication of expressions where the common like terms could be added and simplified. We also saw the geometrical reasoning behind distributive property. And then we took up a couple of examples based on geometrical shapes, money, and we had some financial application question. And I hope with this you got fairly good idea about how to work with expressions. And in the next lesson, we are going to equate two expressions with equal to sign, and we are going to call it an equation. Once we get an equation, we will be in a position to solve many real life situations very easily. Expressions are the foundation building blocks for the equations which help us to break down the problems into smaller units. And these smaller units, for the given condition, can be combined to get the solution. So I hope you're getting this strategy. In the next lesson, which will be based on algebraic equations, you will enjoy further and taste how do we solve real life questions. I hope you are enjoying this journey. Keep keep up to date, and if there are any questions, keep posting. Thank you and all the best.